Right, standard form then. So, standard form is a system that we use for numbers, and it is really useful if you are dealing with really big numbers or really small numbers. So that's why I use standard form an awful lot in physics, not just me personally obviously, but everyone in physics, because in physics we deal with an awful lot of really big numbers if we're talking about like numbers to do with space, and also really small numbers, so if we're talking about numbers to do with the size of atoms and things like that. Anyway, if a number is written in standard form, it's got two parts. So the first part is a number that's between 1 and 10, but it cannot be 10, right? And it also then is being multiplied by a power of 10. So you've got a number between 1 and 10, so like 2.4 multiplied by a power of 10, so 2.4 times 10 to the 8 or whatever it is. So what you need to be able to do first of all is to convert ordinary numbers into standard form. So for example, if we have 285 million here, we need to write that in standard form. So the first thing I do is figure out this first part, so the number between 1 and 10. For this one, that's going to be 2.85. Now, I knew that because I just took the digits that are here and thought, right, well, where could I put my decimal point in this to make this be a number between 1 and 10? If I put it in here, that would be 28.5. That's obviously not between 1 and 10, so it has to be in there. So 2.85 multiplied by 10 to the power of something. Now to figure out what that power is, you take where the decimal point originally was. So the decimal point is originally here, and count how many places it has moved to get it to its new position, which is there. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's times 10 to the power of 8. Now, some teachers will tell you, right, well, if your decimal point has moved to the left, it's a positive power, and if it moves to the right, it's a negative power. That's fine, but I personally struggle to remember which one's left and which one's right. So I just think if it's a really big number like this, it's a positive power. If it's a small number like this next one we're about to do, then it's a negative power. So whichever works for you, everyone remembers things in different ways. So let's look at this next one. So we've got 0.0004021. To get this to be a number between 1 and 10, our decimal point is going to have to go there. So that's going to be 4.021 multiplied by 10 to the power of, decimal point has moved from here, so that's 1, 2, 3, 4 places. So times 10 to the minus 4. And again, depends on what way your teacher taught you, because the decimal is going to the right, it's a negative, or the way I personally remember it is if it's a really small number, it's a negative power. Okay, let's look at going the other way round then. So if you have numbers that have been given to you in standard form and you have to write them as ordinary numbers. So, where's the bottom of the page here? Right. 1.03 times 10 to the 7. This here number tells you how many places your decimal point has to move, and whether it's positive or negative tells you whether it's a big number or a wee number or a wee tiny number. So the first thing I do, well, I'll have a wee think first of all, to be honest. This here is going to be a big number, so I know I can start writing these. My digits I'm going to be writing are 103, right? This 7 tells me my decimal point has had to move 7 places. So the decimal point was originally here. I've currently written the number 103. That would be if it was 1.03 times 10 to the 2, because the way I've written that, the decimal point has moved 2 places. So 1, 2, 3, 4, 5, 6, 7. Now, I never trust myself to do this right, so I'll always check it. My decimal point was originally here. I had to move it 7 places. 1, 2, 3, 4, 5, 6, 7. So that's that number written as an ordinary number. The next one, 3.5 times 10 to the minus 6. I'll have my first little thought, right? This is a small number, So these digits are going to be over here somewhere, and I just leave a big gap. So my 3.5, I have to move my decimal point 6 places. So if I was putting it here, that would be 1, 2, 3, 4, 5, 6. Again, I never trust myself. Let's check it. It was originally here. 1, 2, 3, 4, 5, 6. Okay, so that's that done. The other things that you need to be able to do with standard form is if you're given numbers in standard form, you need to be able to calculate with them. So we need to be able to multiply and divide, and we also need to add and subtract. If you're multiplying and dividing, then what you need to do is just treat the number bit as a normal multiplication, and then you can use your rules of indices to deal with the power of 10 bit, is how I have so elegantly worded it here, right? So 2.3 multiplied by 1.2, I will do that off over at the side somewhere. So 2.3 multiplied by 1.2, this will give me a good chance to revise multiplying decimals with you. If you're multiplying decimal numbers, ignore the decimal point until the end. So I'll do this as if I'm doing 23 multiplied by 12. So 2 3s are 6, 2 2s are 4, put in my 0, 3, 2, add these two together. Hopefully I haven't made any silly mistakes here, probably have. Now, 276 is what I would get if I did 23 times 12, but obviously I haven't done that. I've done 2.3 multiplied by 1.2. So then I look and see, right, there's 2 digits after my decimal point here in my question, so there has to be 2 digits after my decimal point in my answer. So that gives me 2.76. So I know 2.3 multiplied by 1.2 is 2.76. Then for the power bit, whenever you're multiplying with indices, if you remember, it means you add the powers together. So times 10 to the 4 multiplied by times 10 to the 6 is going to be times 10 to the 10. And I've just got that 10 from adding those two powers together. Right? Example 2, 6.4 times 10 to the 7 divided by 3.2 times 10 to the 2. I've given myself two easy numbers here. 6.4 divided by 3.2 is 2 times 10 to the, we're dividing, the rules for indices whenever you're dividing is you subtract the powers, so 7 take away 2 gives me 5. Okay, then adding and subtracting, you can't use that wee sneaky rule whenever you're adding and subtracting. For this you have to change to an ordinary number first, and I reminded myself here to remind you that by ordinary number, like 2 or 2.7 or whatever it is, really I should be saying it's a decimal number, right? Like the decimal system of numbers. Okay, so if you're adding and subtracting, it's actually a little bit more awkward because you do have to change them into your ordinary numbers first of all. So 2.3 times 10 to the 4 is 2, 3 times 10 to the 4 tells me that's moving 4 places. 1, 2, 3, 4. Check it. 2, 3, 4. Yep. Plus 1.2 times 10 to the 6. So 1, 2, 3, 4, 5, 6. Check it. 1, 2, 3, 4, 5, 6. Now, if I just try and do this right now, I will mess it up. So I do really need to rewrite it. Didn't put my equals sign in there, look. So, and be super careful here that you line everything up properly so that everything keeps its proper place value. Okay, hopefully I've done that right. So that's what I get. Now, this I need to change back into a standard form number. So my decimal point is here, so I have to go 1, 2, 3, 4, 5, 6 to get it to there. So it's going to be 1.223 times 10 to the 6. Right, next one. We've got 2.8 times 10 to the minus 3 take away 2.3 times 10 to the minus 4. Again, we need to write as ordinary numbers first of all. So 2.8, I take out my decimal and I move it 3 places. 1, 2, 3. 1, 2, 3, yep. Take away 2.3 times 10 to the minus 4, put my 2 and my 3 down, and I have to move my decimal point 4 places. So 1, 2, 3, 4. Check it. 1, 2, 3, 4. Yep. Again, don't try and do this in your head. You are more likely to mess it up, or, well, I know I am anyway. So 0.0028. Take away, line up your decimal points. There we go. Now, 3, I need to add in my wee 0 there. So I can't take 3 away from 0. So we borrow 1. So 10 take away 3 is 7. 7 take away 2 is 5. 2. Okay. And then change that into standard form. So it's going to be 2.57 times 10 to the 123 minus 3. Okay, that's it. Bye.